Okay. All right, here we go. Summation notation. Yes, it starts out easy, Liv. I try to make it easy at the start so we can go. No. Summation notation. Hey, Trey. All right. So how would we write summation notation of this? Okay. So n equals 1 to 5 of n in this case. Zoom in. Like that? All right. Yeah, because that's my part of the screen that doesn't work. So now that I zoomed for the blind boy, I can do it like that. Okay. So what does this mean? Okay, because you got to understand summation notation, or else we're not going anywhere. So what this means is when I put in my first number, it's 1. Then when I put in my second number, it's 2. When I put in my third number, it's 3. Fourth number, 4. And my last number is on top is 5. So 1 plus 2 plus 3 plus 4 plus 5 is represented by this summation notation. Okay? Okay. Okay. So, all right. So on this one, how many numbers are there? 5. So we'll go n equals 1 to 5 again. Okay. So how do I get to 7, or what's the relationship between these numbers? So we add 2 each time. Okay. So we're going to add 2. So it's like n plus 2, but we're starting at 7. So no, not 7n plus 2. So could this be 5n plus 2? If we put in a 1, we get 7. But if we put in a 2, we get 11 or 12. So that doesn't work. Okay. Not quite. Okay. So we got to figure out, how are we going to get this? Well, this kind of comes from an arithmetic sum. Okay. If you can remember arithmetic sums, there's t sub 1 plus n minus 1 times the common difference. Okay. What's my first term? 7 plus n minus 1. What's my common difference? 2. So if I do the math, 7 plus 2n minus 2 is 5 plus 2n. Wait, isn't that what I had?
Yeah. No, you had 5n plus 2.
Oh, that's what yeah. So 5 plus 2n, if we put in a 1, we get 7. If we put in a 2, we get 9. If we put in a 3, we get 11. If we put in a 4, we get 13. If we put in a 5, we get 15. Okay? So this is summation notation of this. Okay?
So the add equals is always going to be 1?
Oh, it could be 0 or 1
And so the top will always be the number
of terms. Yep. The top is the number of terms.
And then the one before that is a relationship. This doesn't seem too bad until you're going to be adding like first and second.
Okay, so this is something that we used to teach in pre-calculus, okay, to kind of get people ready for calculus. All right, so here's summation notation right here. So this time we started at 0. So if we stick 0 in for J, we get what? 3. we get 3. If we stick 1 in for j, what do we get?
0.
If we stick 1 in for j, what do we get?
3 minus n.
Okay, so the first term is 3 if we put in a 0 for j. If we put in a 1 for j, we get 3 minus n. That's 1 for j.
What's the
I can see that.
N is just n. N is just n. It's a variable. If we put in a 2, what are we going to get?
3 minus 2n.
If we put in a 3, or how many terms are there? There's 4 terms because we go from 0 to 3.
So how many you went to?
So it's 3 minus 3n. Okay, so we're looking for the answer that looks like this. 3 minus n, 3 minus 0, 3 minus n, 3 minus 2n, 3 minus 3n. So they did put the 0 in, not that they needed it, because I didn't put it in. But D would be the answer. Trey.
How come if 0 is another term, why do you have a 3 over the e?
Because there's 3.
Because it goes from 0 to 3, which is 4 terms. Because 0, 1, 2, 3.
Yeah. Is it 0, 1, 2?
Because my first term was j equals 0, j equals 1, j equals 2, j equals 3.
No, that doesn't make sense. He's right. You're wrong. No, because you.
Who's wrong?
You.
I'm not wrong.
This one had 5.
Okay.
Yeah, because I started at 1. See, 1 on the bottom.
2, 3.
So if we have start at 0, 0, 1, 2, 3, 4 terms.
Oh, 3 on you. Because the 0 is no.
Because you.
That's not it. Here's my back up. Because on the last one, you don't write 15.
1, we started at 1 and went to 5. 1, 2, 3, 4, 5. 5 terms. Here we started at 1 and went to 5. 1, 2, 3, 4, 5 terms. Here we started at 0 and go to 3. So it's 0, 1, 2, 3. So that's 4 terms.
One less than one.
That's
4 times.
I'm with you.
It
I
should
agree.
be 4. It
Ah.
should be 4.
How
Why
would
is
it
it
be
not 4?
Because last time you didn't start at 0. Last time you started at 1.
So
So
they just
there's
don't.
only 5. So this time you started at 0. So you go
Trey.
4, which is the 3.
You're smart. What?
Yeah, that's just silly.
Yeah, you're using 4 numbers.
Yes. No, you're using 4 numbers and you're counting 4 of them.
If you started at 1, then
You're using the number 0. That's one number. We're using the number 1. That's a second number.
I agree. I understand why you're using all the numbers, but I don't understand why there's a 3 on top of 3.
Because we're going from term 0 to term 3, which is 4 terms.
Yeah.
So this is our ending term number.
Oh,
And we go a step one at a time.
I got it now. That's on me. Okay. That's on me. My bad.
All right. You're going to have a total migraine when you go to lunch here. All right. All right, here we go. Look at this one. Okay. We ready? All right. So on this one, hey, we start at 1. So how many terms are there going to be? 4. Okay. So I can try either of these in here. So let's just try A first. Okay. If we put in a 1, we get -2/5, right?
Yes.
If we put in a 2, we get -2 over 6.
No.
So that doesn't work.
Yes, sir.
So if we put in a 1 here, we get -2/5. If we put in a 2 here, we get -2/7. If we put in a 3 here, we get -2/9. If we put in a 4 here, we get -2/11. This is the answer.
Pretty sweet.
Okay?
How come there's not an N in that one?
They can use any letter that they want to use.
Last time there's 2 variables. There's
There's
a J.
a J and an N. But this one, there's only a J. And here they use I. not guess and check. Well, we're plugging in the answers. So here, how many terms are there? 4, because we start at 0 and go to 3, so that means there's 4 terms. Yep, 3 is not the number of terms. 3 is our ending term, the last term. She don't get it. Okay, so if we stick in a 0 to the first one, we get 0 plus 0 plus 4, which is 4. That works. If we put in a 1 here, we get 1 plus 2 plus 4. What's 1 plus 2 plus 4? Not 25. Okay, so if we stick in a 0 to this one, we get 2 squared, which is 4. If we stick in a 1 here, we get 5 squared, which is? If we stick in a 2 here, we get 8 squared, which is?
Are you just assuming for the last one?
I'm assuming.
That's dangerous.
I did the math. I checked it out.
In the first 3 or like
I just need interval.
Okay, so now let's connect summations with what we just got done learning. Breezy, are you catching any of this? Instead of being on your computer, you should mutually participate in this class. Okay. All right. So, is this a left Riemann sum, or a right Riemann sum, or a trapezoidal sum, or a midpoint sum? This is a left Riemann sum because our triangles hit the function on the left side of the triangle or the rectangle. Okay, that's why it's a left Riemann sum. Good. All right, so how many divisions are there for each number? 3. Okay, so how many total divisions are there? 6. So 0 to what would give us the total number of divisions?
There's 7.
Okay, time out. How many divisions are there?
I know there's 6.
6 total divisions. So if we start the first number at 0, where would the last number be? 5. So those two are gone instantly. All right. So, all right. So each function, each rectangle is how wide if it takes 3 of them to make one? 1/3. 1/3. 1/3 is the width. Okay? What is the height? Well, the height comes from the left Riemann sum. So the first rectangle has a height of 0 is the height. The second one has a height of 1/3 cubed because you put 1/3 into the function. The second one has 2/3 cubed. The third one has 3/3 cubed, and so on. So, what function is, as you put in each number, if you put in a 0, you get 0/3 cubed. 0 cubed is 0. And then you put in a 1. 1/3 cubed times the width of it, 1/3. Hey, it must be this one because this one goes by halves, and that doesn't make sense. This is the height. This is the width. That doesn't make sense. Okay, we're getting to that, Liv. All right. Liv, you are on top of it. It is a right Riemann sum. Breezy, why is it a right Riemann sum? You are so good. You don't pay attention and still know what's going on. All right. All right. So, where do we start? Where do we end?
Well,
Huh.
Oh yeah, 4 terms.
There's 4 terms. How many terms per number?
2.
3, it looks like to me.
Oh,
1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So how many rectangles do we have?
12.
12 rectangles. So it goes from 1 to 12. Oh, shoot. All of them are 1 to 12. So we can't eliminate any there. All right. What's the width of each rectangle? 1/3 is the width. Okay. 1/3, not 1/12. 1/3 is the width. Width. Eliminate. Yo, we're doing good here. So, where is the first right Riemann sum at? Well, it's at 1 plus 1/3, right? So if you stick in a 1, it should be somehow 1 plus 1/3. So if you stick in a 1 to this first one here, stick in a 1, you get 1/3 plus 3. Okay? And if you cube that, that's 3 1/3 cubed. That's going to be a lot bigger number than this, right? Here, if you stick in a 1, it's 1/3 plus 1. 1/3 plus 1, which is 1/1/3 cubed, which is right here. And it's 1/3 y. If you put a 2 in, that's 1 2/3 cubed. If you put in a 3, that's 3/3, which is 1 plus 1, which is 2 cubed. So it must be this one. Okay? All right.
That's midpoint for sure.
Absolutely, Trey. It is midpoint. Okay, the rectangles are wide. So this is -3, this is -1, this is 1, this is 3. Okay? So how many rectangles are there?
3. 4.
4. You don't see the middle one, but there's 4 rectangles there. So we go from 0 to 3. So we're good there. So all of them are still in play. How wide are the rectangles?
2.
2 wide. Why can I eliminate those two?
This is 3 on the top.
No,
That's
they'll.
not bad. You have to times it by 2.
You have to times it by 2. You have to take the height times the width. So at -3, if we put -3 into this function, what's the height of the first one? 16. If we put -1 into this function, what's the height of this one? 4. If we put 1 into this one, what's the height of this one? 0. And we put 3 into this one, what's the height? 4. Okay? So we want to get a height of 16, 4, 0, and 4. So if we stick in 0 into this function, okay? Put in a 0, you get 2 times 0, which is 0, minus 5, which is -5. -5 squared is 25. Do we have any heights at 25? No. Well, we don't worry. The 2 is the width, so we don't really worry about that. Because I'm talking about height right now. So if we put it,
When you're looking for height, you don't times it by 2.
nope, that's the width. So we can find the area under the curve. All right, so if we put in a 0 here, we get 0 minus 4, which is -16. -16 squared is, or we get 0 minus 4, which is -4. -4 squared, which is 16. Height of 16 with the 2. That works. If we put in a 1, 2,
You put 0 in, you got 16.
put in 0.
Yeah, but
0
how does that?
minus 4 is -4. -4 squared is 16.
But why'd you put in 0? But how does 16 and 0 correlate right there? Shouldn't you put in
You
like?
just plug it in the first
We're
line.
plugging the first term in. Put in 0 is our first term. Then we put in a 1.
Happens to be one of the heights.
Yeah.
was 4, would that have said that's good too?
If what's 4?
If 0 ended up being 4, because 4 is a height.
I don't know how to answer that because I don't want to.
Don't you plug in every number from 0?
Yep. Yep. So if we plug in a 1, 2 times 1 is 2, minus 4 is negative 2. Negative 2 to the squared is 4. That's my height there. If we plug in a 1, 2 times 1. Oh, and then if you put in a 2.
I'm getting it now.
2 times 2 is 4. 4 minus 4 is 0. 0 squared is 0. That's a height of 0. If you put in a 3.
4. Right?
If you put in a 3, you get 6 minus 4, which is 2. 2 squared, which is 4. All right. Last one of these. Last one of these, and then we get on to the difficult stuff. Because this is the easier stuff of today. No. We're learning first. Hey, this is a left Riemann sum. Good job. Okay? All right. So, how many do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I go 0 to 9. That makes sense. Okay? Because there's 10 of them. Come on. Erase. All right. So, the width is what? 1. So 1 times anything, they don't have to write the 1 in there. Okay, so we know, you know what, Kylie? The width is 1. Yeah. You think it's B. Well, let's try a 0 in here. What's 0 minus 2? Negative 2. What's the absolute value of negative 2? 2. So 0 gives us a height of 2. Hey, that works. Put in a 1. 1 minus 2 is negative 1. The absolute value of negative 1 is 1. That works. Put in a 2. That works. Put in a 3. That works. And so on, and so on, and so forth. So those of you who guessed that right off the bat, yep, you're right. It wasn't a guess. It was you guys are just smart. Okay. Now, here we go. A definite integral as a limit of a Riemann sum. All right. So, we're not going to watch a video. I'm just going to go through this with you. Okay. What we're getting to is finding the area under a curve from a certain spot to a certain spot. This one is from 2 to 6. You don't see any rectangles yet, right? It's smooth. What this is the integral. Get rid of you. It's the integral. Oh, it won't let me draw because I'm on the internet. It's the integral from 2 to 6 of that function. And the dx, this is where it gets crazy. The dx is the width of these rectangles that go up and down. So what we're doing is making the width of the rectangles so small you can't even see the rectangles anymore. So just like lines. Okay, what does that look like? So we start with rectangles. Okay, see how we have rectangles? And now we take this, make the rectangles so small that it's just smooth in there. See how that works? Okay, so that's doing an integral. So when we do an integral, we take what we had for rectangles and we keep making more and more and more and more rectangles. What we do is make n, the number of rectangles, go to infinity. So that's like what we learned at the start of the year, a limit. As n approaches infinity, what is going to be the area under the curve? Because if we start with, and if I could pause this, we'll get to it in a second. We start with one rectangle, but really I would go 1, 2, 3. We'd start with like 4 rectangles, and then we'd make 8 rectangles, and then 16, and then so on. And then as we get n higher, it's a better approximation. See how we started with like an approximation 28 when we had one rectangle, and it gets down to basically 14. The area under this curve would be probably 14. Okay? So as the number of rectangles goes towards infinity, then we get an actual area under a curved surface. Okay? And that's what Newton and Leibniz did when they basically invented calculus. They worked on this to find the area of the curve, and they got calculus out of this. Now, what happens is in another couple weeks, we'll learn about antiderivatives and how an integral is really an antiderivative. We're going the opposite direction of derivative. And they kind of discovered that, and then they plugged derivatives and this all together, and then it's like, oh, now we have calculus. Okay? So that's what happened. Okay, here's the important part. Okay. So the change in x is how wide our rectangles are. So we take the top number that we're evaluating and see how we went from 2 to 6. From 2 to 6. So we take that top number that we're evaluating, 6, minus the bottom number, 2, and we divide it by the number of rectangles that we have, which in this case is n. And as n it goes towards infinity, then they get super skinny rectangles. Okay? So if we had 4 rectangles, 4 over 4, they'd be a width of 1. Okay? You kind of get a little of this. Okay? So this is the change of x. Okay? How wide your rectangles are. And then this other part, okay, x1 equals your bottom number plus change in x times I. Okay? And that's how we're going to come up with what goes in the summation. The bottom number plus how much it changes, each rectangle changes, times the letter I, and I will be the bottom number of your summation notation where we start at 1. Okay? And then we go through. And we're going to figure this type of thing out from the original. Okay? Now, notice how the original function was 1/5 x squared. So we take that I, or x sub I, and take 1/5 x sub I squared, and then we put the width of it in front of it, okay, or the width of it right there. That's the width. And so then what they did is just multiply the 1/5 times the width. Okay, and that's how they made up that function. All right, so writing Riemann sums. Okay, we just went through that. So here we go. Let's see if we can do this. Okay, so on this one, and those poor people who are sick today don't get to see what I'm writing on the board, but here we go. Where do we start? 0. Where do we end? 3. So we go 3 minus 0 over n. Okay, what's 3 minus 0 over n? 3 over n. That is the width of our rectangle. And now we got to find the height of the rectangle. So we have to do x sub I. X sub I is our bottom number plus I times the width. So what does this calculate out to be?
3 over ni.
3I over n. Okay? So you plug it into the function. What's our function? E to the x. So the 3I over n goes in for the x of e to the x times the width of 3 over n. So which one has that? So it's e to the 3i over n, e to the 3i over n. Well, that would be c times 3 over n. So it'd be c. Let's try c. Check. Cha-ching! Good job, Enoch. Okay, let's do another one. All right. I don't like yellow or green. Let's go with black marker. All right. So this one goes from 1 to e. What's our top number?
E.
E. Bottom number.
1.
So it's e minus 1 over n. That's the width. Okay, that's the width. And then x to the I is the bottom number, 1, plus the change in x, e minus 1 over n, times I. Now, we'll just leave it like that. Yeah, we'll just leave it like that. Okay? So I want this somewhat times this, and this will have an ln in front of it. ln of x dx. Okay? So which is our summation?
C.
Looks like C. 1 plus e minus I over n times I, and then the dx is e minus 1 over I. If I was writing it, I would write this part last. I would write this part, then in parentheses times that part. But hey, it's not me. They wrote it. We're good. Okay? Common mistakes, blah, blah, blah. Okay, now this, we're working backwards. So what does this represent as far as down here? Okay?
4.
So d sub x equals 4 over n. Okay? We start at 3, and we add on the 4i over n, so change of x and that. So we start at 3, and we go from there. What is change of x in the expression? Well, that's dx, that's 4 over n, right? So that should be d. All right. This is the one where I struggle with. I struggle with this one. Okay? What's dx?
Dx is 5 over n.
5 over n. Okay? So then the function where we start is 4. So where we start, plus 5 over n times I. So we start at 4. Which of these starts at 4?
B and D.
B and D. Okay? So we start at 4. So it's the square root of our function. Since we start at 4, that's part of it. So the only thing in there, because this is exactly how it appears here, this goes in there. So it is just plain and simple x. So it is just D. And I know that's hard to see because the first time I did it, I wanted to go 4 plus x because it's 4 plus. But no, this is our starting number plus the change in x over I. Okay? So, Riemann sum stuff. All right, I'm going to sign it out now. Okay? And you have the rest of the period to work on it. I'm not going to talk about anything else after lunch. Okay? But this stuff takes a little bit to get down. So, you got it? All right, I'm going to